Though our galaxy is an immense city of at least 200 billion stars, the details of how they formed remain largely cloaked in mystery. Scientists know that stars form from the collapse of huge hydrogen clouds that are squeezed under gravity to the point where nuclear fusion ignites. But only about 30% of the cloud's initial mass winds up as a newborn star. Where does the rest of the hydrogen go during such a terribly... It has been assumed that a newly forming star blows off a lot of hot gas through lightsaber-shaped outflowing jets and hurricane-like winds launched from the encircling disk by powerful magnetic fields. These fireworks should squelch further growth of the central star. But a new, comprehensive Hubble survey shows that this most common explanation doesn't seem to work, leaving astronomers. Researchers used data previously collected from NASA's Hubble and Spitzer space telescopes and the European Space Agency's Herschel Space Telescope to analyze 304 developing stars, called protostars, in the Orion complex, the nearest major. Instead, they found that the cavities in the surrounding gas cloud sculpted by a forming star's outflow did not grow regularly as they matured, as theories propose. In one stellar formation model, if you start out with a small cavity, as the protostar rapidly becomes more evolved, its outflow creates an ever larger cavity until the surrounding gas is eventually blown away, leaving an isolated star, explained lead researcher Nolan Hable of the University of. So, there must be some other process going on that gets rid of the gas that doesn't end up in the star. The team's results will appear in an upcoming issue of the Astrophysical Journal. A star is born during a star's relatively brief birthing stage, lasting only about 500,000 years. The star quickly bulks up en masse. What gets messy is that, as the star grows, it launches a wind, as well as a pair of spinning, lawn sprinkler-style jets shooting off in opposite directions. With its gas tank empty, the star stops accreting mass. In other words, it stops growing. To look for cavity growth, the researchers first sorted the protostars by age by analyzing Herschel and Spitzer data of each star's light output. The observations were taken between 2008 and 2017. Although the stars themselves are shrouded in dust, they emit powerful radiation which strikes the cavity walls and scatters off dust grains, illuminating the gaps in the gaseous envelopes in The Hubble images reveal the details of the cavities produced by protostars at various stages of evolution. Hable's team used the images to measure the structure's shapes and estimate the volumes of gas cleared out to form the cavities. From this analysis, they could estimate the amount of mass that had been cleared out by the star's outbursts. This has been pretty fundamental to our idea of how star formation proceeds, but it just doesn't seem to fit the data here. Future telescopes such as NASA's upcoming James Webb Space Telescope will probe deeper into a protostar's formation process. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.